Hi, I'm calling Cambrian. I'm a student here at Cambrian College, and my student ID is A00322844. Today I'm going to be going over Ordinary General Annuity question with using the BA2 Plus calculator to answer a question. So to start, we're going to go over some of the components and variables that we'll be using to answer our question and that we'll be using to input in our calculator as well. So we'll start with we have a present value, which is PV, and then we have FV for future value. So we'll always have one or the other. We have IY, a nominal interest, so nominal interest rate. It can also be considered as a annual interest rate. Then we have CY, the compounding periods per year, um, which relate to the nominal interest rate. So how many times does the nominal interest rate get compounded throughout the year um, based on those compounding periods? Similarly with PY, which is payment periods per year, the PY relates to PMT, payments made at each payment period. So PMT relates to PY similarly to how CY will always relate to IY, but don't get the two confused because they're still separate. IY will relate to CY always. PY will always relate to the PMT part of the components. Next, we have N, which is the number of payments in a term. More simply put, the total amount of payments throughout the entire term or throughout the entire defined time that you are paying, making these payments to or receiving these payments from that somebody. So it's always at the end of that payment period that the payments get made. So N is the total number of payments throughout the entire term. So next we're going to go over compounding periods and payment periods per year and what those values include, which is how many times does the interest rate get compounded throughout the year, how many payments get um, paid throughout the year, like how many periods throughout the year. So this can be valued as annual uh, payments or compounding periods. So annual meaning just one time throughout the year, semi-annually meaning twice in a year, so every 6 months, quarterly, 4 times throughout the year, every 3 months, or monthly every month, which would equal to 12 times throughout the year for 12 compounding periods or 12 payment periods for the year. So those will always kind of be referred and inputted for either CY or PY for how those compounding periods or payment periods will be. So a little bit more detail in regards to our components, in regards to PV and FV, our present value and future value, one or the other will always be zero. So if we're starting with a present value um, of zero, then that means we're solving for a future value. So that means we start at zero for present value, we're making payments until we accumulate a future value that we will solve for. Similarly to if we have an amount that we're solving for present value, that means our future value is zero. So future value is zero, we have a present value, amount that we're solving for, making payments throughout those payment periods until we reach an amount, a future value of zero. Um, so again, if present value is zero, then we're solving for a future value amount. If future value amount is zero, then we're solving for a present value amount. So the other thing to look out for is present value will always be entered in the BA2 plus calculator as a negative. If we don't have a present value amount, if it is zero or if we are solving for PV, then payment will be entered as a negative. However, if there is a PV amount that we are inputting in the calculator, then payment will always be positive. Present value will be entered as a negative. Payment will be entered as a positive. If there's no present value, or if we're solving for present value, then PMT is negative. So let's carry on to the question. So now we have our annuity question. Since landing your first full-time job, you saved $450 at the end of every month for the past 3 years. So we kind of have an indication for our first half. So you saved 450 at the end of every month for the past 3 years. Okay, so we have like one half of the timeline. Now you want to use these savings, the accumulated savings, at the end of the 3 years to fund an extended stay in Vienna, Austria. How long in months can you support yourself by withdrawing $3,700 at the end of every month? Assume an interest rate of 4.65% is compounded and semi-annually throughout the entire timeline. So throughout the first half and throughout the second half. We can see that the first half was saved 450 every month for the past 3 years. So okay, we saved, start at zero, we saved, we have a future value amount that we will solve for to then be able to figure out the second part. So how many times, how many months can we withdraw 3,700 until we reach a $0 amount? So how many months until we reach no more money? So we'll start with the IY and CY, the nominal rate, and the compounded period per year, because that will never change throughout the entire timeline. That will always stay the same. So we could always include in our timeline. As you can see, I've already started a timeline just to show the point in time and the certain payment periods. So the payment periods will be indicated as notches across across our timeline. So we're gonna start with the IY and CY because that will never change. So IY is the nominal rate, so 4.65. And then the CY, the compounded period, so compounded rate semi-annually. So that means 2. So CY will equal 2. So here we'll add it to our timeline. So IY 4.65%, CY equals 2. Next, we're going to look at the payment periods in a year, the PY. So we can see that the first half of the timeline, we made payments to save, and we made payments every month. So that's monthly. So that means making payments monthly, that's 12. So CY would be 12. And then in the second half of the timeline, we can still see that the payments withdrawn of 3,700 is at the end of each month. So that's monthly as well. So throughout the entire timeline, our payment periods, our PY, will be monthly. So payments are monthly. So we know that IY, CY, and our PY, our payments, are all the same throughout the entire timeline. So now we're going to go over and start today. What do we have today in our question that we're starting with? So today we start with $0 because we won't be making our first payment until the end of that first month, at the end of the first payment period. So today we start with $0, so that's the present value. The first payment period, so at the end of that first payment period at the end of the first month, then now we will make our first payment of $450. So today we start with 0, we wait a month, then at the end of the month, we make our first payment. Start with 0, month went by, make our first payment, and then we continue. Then we'll be able to determine second half. Um, okay, so sorry, I had to fix that. So we know that we have those payments every month for 3 years. So 12 times in a year, we have it times 3. So we know that 12, 24, there's going to be 36 payment periods. So if we do a quick calculation even of 12 payments in a year times 3 years, it's 36. So here we know that we'll have 35, and we'll have our final 36th payment at the end of the 3-year mark. So here we have our payments. We have the dotted lines to show a break in the timeline, but does it just so we don't have too much information on our timeline. We just need enough to show that, okay, we start with 0, our end of the accumulation is at the 3-year mark. And here we will have the future value, which we're figuring out. So with that first half of the timeline, we're going to include our arrow. And with every arrow, we always have an n that we include. So we know that n, the payment periods, in that term, the first half of the timeline, is 36. So we have 36 payments. So next we're going to add our variables, and we're going to solve for it. So we have our present value 1, which is $0. We start at 0. Our future value is what we want to figure out in order to figure out the second half. We have our IY, CY, and PY will always be the same, so 4.65%. Compounding periods per year is always 2, semi-annually throughout. Payment periods per year is 12, so it's monthly. Our first payment is $450, and then for our N, 36, so we calculate years times PY, so again, 3 years times PY, which is 12, 36. So for the second half of the timeline, now we're determining how many months. So we know that there's payments in the second half being made, and then the future value at the end will be 0. So now we're to figure out the second half of the timeline, which again, we'll have a second arrow now. And with the second arrow, we have our second n that's always included. So now we'll enter our second amount of variables. We know that future value 2 will be 0, because for the first half of the timeline, when we figure out the future value of the first half, future value 1 will become PV2. And this is where we don't round, and then PV2, that's where we start withdrawing money until we reach 0. So we know PV2 is still uncertain. So that's question mark. We have future value that is 0. IY, CY, and PY are all the same throughout still. Our PMT2 is now 3,700 because it's the second half. And we're figuring out for the final answer, what is the amount of months? So how many months, what is the number of payments in that term? So we know because it's the second half, the second payment amount of 3,700 is withdrawn monthly. That gives us an indication. So now we're gonna start doing our calculation in our calculator. So we always start BA2 plus by clearing TVM. So we do that by pressing second, clear TVM. Now we can enter IY 4.65, press the IY button. Next, because present value is 0, we have to enter our payment, PMT, as a negative. So first payment for the first half of our timeline, 450, negative, press payment. Now it's set. Next, our N for our first one, so 36 payment periods for the term, press N. Next, we're going to enter our PY and CY. So we need to access the PY menu. So if we press second, we can see a little PY above the IY button. So we press that. Then we can enter 12 for PY and press enter. Then if we press down, the down arrow, we will access the CY option. That's where we enter 2, enter to set it, and then we can press second and quit, press compute to quit. So just to go exit out of that area. Now that we have all of our components inputted, now we can press the compute button and press FE to compute the future value of our first half. So 17,336, and we have all those decimals. So now we don't round at this point because the question is not specifying that we withdrew anything. We just saved until the 3-year mark. Now we're going to withdraw from that fund. So it never went out, so we keep all the decimals there. So as we continue, so now we have the present value 2. So now we know what it is. We know that the FE is this amount. So now we know exactly what it is. Now we'll continue. So now that we have our future value, we're gonna transfer that as the present value now. So what we can do, because we already have the future value on your calculator, all you have to do is press negative, which will input that negative amount, and then you can press PV. Without re-clearing your TVM, that initial part at the top, 2-second clear TVM to reset your calculator, we could just continue our calculations by moving that future value amount just directly to the present value. So that's where, again, future value, make it negative, turn into PV, and then that's where we have to make sure our future value is now 0, and we have to make sure that our payment, because we have a present value that's negative now, our PMT is now positive, and now we have our N that we can compute. So compute N, and we have the amount. Now that full amount, we will round up to a total of 5 payments. So here we have a total of 5 payments that are made monthly. And here we have our answer for the question. So thank you very much.